the loss of income due to the pandemic and so on. So some countries must finance themselves with debt, and because they don't have a positive balance to compensate that. So it will imply an increment of interest rates that might imply default in the future. So this usually occurs in several countries. The interest rate has increased for several countries, including Colombia, Brazil, and Argentina. And in the case of Brazil and Argentina, it will increase the possibility of default. And in fact, both countries we have suffered with default previously. So this is like a potential problem that we may have. So it's something we would like to analyze here. The idea here is try to define a Ramsey model, that is a model that analyzes optimal taxation. And we use the idea that it was given by Diamond, Mirrlees, Ayagari, and Shamli in very seminal important papers, in which they analyze optimal taxation with different environments. However, all of them, included Auenbach, assume that the agents are homogeneous in some ways. Some of them are completely homogeneous. Some of them has idiosyncratic shocks that produce some kind of heterogeneity among them. However, in most of the cases, they have the same utility in all cases. The only models that they consider heterogeneity in terms of the preferences are ASIC, I don't know how to pronounce properly, ASIC, Goss, and Chien and Lim, that they have optimal capital taxation economies and infinite horizon models with incomplete markets and endogenous government spending. However, the only problem with this type of papers is that the central planners don't anticipate part of the demand. So they establish a fiscal policy, taxation and so on, and they try to resolve the optimal taxation problem. However, they cannot estimate what agent could do because of that taxes. So they assume like the agents are so they are like a price. They don't analyze the impact that they have on the agent. So this is like this is something that several papers does like Shamli, but they cannot do it. It's a very complicated mathematical problem. So our goal is try to see something like this to analyze that case in which you anticipate this. You can anticipate in some ways the demand. So we have in our model we consider a public expenditure model in which you have endogenous but bounded away from zero expenses, and also you have a very negative shock that force the government to spend more. And this is optimal to do. He's an endogenous type of spending, and in fact, it's going to be optimal for him to spend that amount of money. Like, for example, in a situation that we have here, we have the pandemic and so on. So the idea here is that we have a sequential economy. We have several periods. I have a central plan that decides the taxation and consumer that it will consume and decide what to do. And the idea is that the central planner can estimate in some way the aggregate demand function. He doesn't know which equilibrium will occur, but he will know more or less how the demand behaves. And in fact, central planners can estimate in some ways this type of demands. And so it will behave like a Stackelberg game in which the central planner decides in advance, and he knows more or less what the economy will behave in some ways. So to simplify this model, this is a 3-period model. It's an infinitely lived model with heterogeneous agents, with heterogeneous type of preferences. In this case, we don't have production, but I would like to do it in the future. And there is a bond that is used to finance to the government to finance themselves, and also it will work as a way of saving money for the agents. So the agents can save money from one period to the other one by buying the central planner bond. So in this case, Ramsey taxation property holds. What it means that taxes are higher for markets with less price elasticity. So the taxes will affect more the poor people than the rich ones, that they are the ones who consume more the elastic goods. And we also show that default of part of the central planner debt has no real effect on demand. We don't analyze the case in which the default causes some kind of problem for the central planner for avoiding, for example, international market and so on. We don't have that. We assume that he is not gonna be punished. So in the absence of punishment, even though there is no benefit for the central planner to try to default his debt. So we finally also showed that in the case of if you try to see income taxes, in this case for the case of public employees, but more specifically employees that their salary is above the social benefit, taxation, the optimal taxation for income taxes of this type of agents is going to be higher than taxation for the rest of the population. So you must finance. So the idea is that he must try to put like some kind of a temporal tax to try to overcome this situation. More or less, that's the idea. So I'm going to explain briefly the model if I have enough time. So the idea is we have a finite number of agents and a central planner and 3 periods without uncertainty. We have now, there's going to be like, in the case of this pandemic, it's going to be like 2020, 2021. The short run is in a couple of years and the long run is the long run, maybe 20 years, 30 years in advance or 10 years, depending on the country. And the idea is that we have 3 goods, K, 0, 1, and 2. And K equal to 0 is the numerator, and most of them, all the payments for the government, they're gonna made in that numerator. And you have the social planner that has a real interest rate of D. D is 0. That is gonna interest rate in the first period, D1 in the second one, and D2 in the third one. The central planner defines bond supply, taxes, and social expenses. And but it is assumed the price takers similarly as consumers, so they don't affect specifically prices. The prices are the market problem. Taxes are in this case on endowments and net purchases, but not on net selling, and I'm gonna show it later. So you have here, you have like a two period Stackelberg game. So in T equal to 0, you have here the central planner. He decides what to do, and then the market or the agents, in fact, will decide to consume. In this case, don't have a production, but after he decides what to do based on the price that is given and the tax policy, you have the consumption, and then the Russian auctioneer will pick up everything to compute and to find the equilibrium in this situation. And what the social planner observes is this one, is the equilibrium allocation. Because of that, he doesn't observe specifically what the agents do specifically. He observes just only what is the prices at the end and in the next period, and the aggregate allocations and so on. So more or less, this is the idea. So you have a Stackelberg game in this case, and this one is the first one, and then the second one, this one, more or less like that. Okay. Here, the budget constraint for the agent, we have that the consumption of real goods, the assets. In this case, is only the bond. The price of the bond is Q here in this case. This one is also always in the numerator. They pay in the numerator. In fact, we don't have money in this model, and so that's why the returns of the previous period, you have the interest rate, and you have here the price of the good in this one. In fact, this is the price of the numerator, the 0 one only. Here you have the endowment, and you have taxes. Here, this tax is the product of tau and p. So here you have that you are paying a proportion here of what you receive at the beginning of endowment, and then you are paying something that is the difference, the net purchases. Is the difference between what you consume minus what you have as endowments. If you sum these two terms, it's gonna be a tax on X, only X, and this is gonna be like a value-added tax. But if you decide to tax differently income and net purchases, this could be seen as two different types of taxes. So that's more or less the idea that we will have. Also, we have this is the prices I also mentioned. A is the portfolio, and A minus 1 is the initial endowment of the bonds. Okay. The utility function of the agent is a traditional one. It's like a discounted factor utility. Here in this case, they change among all the agents. And also you have that they are increasing, concave, and separable. And this is an important characteristic property. You have that they are quasi-linear. So you have they are linear in the terms of the numerator, and they are concave for the other ones. And they satisfy another condition that is important too. So for the central planner, the idea is trying to, the idea of the central planner is picking up he must pick taxation in this case, the tax rate, the income, no, the interest rates, and also what he must produce of each of the bonds in each period, and the consumption of the agent. Here, this part is for the salaries of the public employees that I'm gonna define later, but it's gonna be more or less here. This is gonna be here, and he also must decide what to do with these endowments. And the budget constraint is a typical one, so he must finance their spending and the interest that they must pay, and he will use the revenue based on taxes and what he can sell as debt. The traditional one. X bar here is the aggregate demand. So he observed only the aggregate demand, and based on this, he made all his computations and so on. So the social planner gives units of the numerator, as I told you. That's why everything is multiplied by, it has to be multiplied by P. And you have also a social welfare function, V, that in this case is the sum of the utilities of the agents. And also you have something that is like a public social part, that in this case is gonna be the health, for example, the public health utility, that you will have a reduction of mortality rates and so on, and you will have the utility given by the salary that you give to the public employees and so on. In this case, to try to analyze a case in which you have a public health situation, for example, like COVID, you must need that the benefit of investing money in the bad event is extremely high. So this is the condition. So once that you have that invest one marginal unit of income in equal time t equal to 0, has a very strong impact on the social welfare in the long run. So this is the condition. This is why it is good to invest now more money than the spending in the future. It's because they will have a short-term benefit that is higher than spending that amount in the long run. So this is more or less why the government will spend money, in fact. And this is like extraordinary situation. So the equilibrium price is more or less straightforward. You have prices, a central planner decision strategy, and strategy of the agents, and you will satisfy the optimality for the agent, optimality for the central planner, and optimality and market clearing for all agents. So the first result is the Ramsey result with heterogeneous agents, in which the proportion of the optimal taxes are related to the elasticity of the goods. So for example, if the taxation is higher for the first good compared to the second one, is because the elasticity of the second good is higher than the elasticity of the first good. So prices with highest elasticity has lower taxation rates. Okay, so this is the traditional result, and this is also in this case it's true in the case of heterogeneous agents. That is something very new. And also we have in the case of the central government, it has the possibility of default part of his debt.
You have 5 minutes left.
Okay, perfect. So in the case if you have the government, central government can default part of his debt, and he must announce that in advance. In fact, that is important. The thing is that the same allocation that can be implemented without default can be implemented with default, but the thing is that the price in t equal to 1 of the bond is lower. So it has because of the default of the agents see in advance that they will default, and so they consume less this asset, the bond, and that's why the price goes down. So because of that, the economy in fact will implement the same economy as before. So in this case, you don't have any punishment for the central planner, and because of that, it seems that it is the same to default or not default in his debt. But of course, if you have a punishment, any type of punishment like being kicked out from the financial international market, this is not specifically the case. So it's worse to default his debt more in this case. The idea in this case is that he must produce more debt in t equal to 1 to compensate that. So this is something that the agents will see. If the agents see that the government will be in debt with a higher proportion, they can know in advance that the government will default in the long run. And this will cause, in the terms of the equilibrium price of the bond, it will make that the price of the bond will go down, and then you'll see like some kind of increment of prices of the real prices in terms of the bond. So that will imply in some ways you see that in this way as some type of inflation because of that. So you can have an effect also in inflation in this case, if you interpret inflation that way. In the case of putting tax income in public employees, so you pick up endowments that you give to some of the agents, and you have that the endowment here is given by this. So you tax part of the wealth that you are giving to them. And you also have other type of taxes of the kind of value added tax that we defined before. And in this case, if the utility of giving that money is lower that the economy has of spending that amount, so they are not helping specifically so much to the pandemics, these salaries that you are paying right now, it is better to tax these people, only these people, and not the other one. So the idea is to reduce consumption taxes and increase taxes just only as short period taxes in these specific cases. And this is the result here. So we have that the marginal tax rate in this case for the case in which for the case of the agents that they are receiving the public employee case is gonna be like this. So the taxation is positive, and the idea is that that is possible. The taxation for the other ones, for the consumption goods, are gonna be lower, and you're gonna be zero in the extreme case that there is not need as much as money as it not needed that amount of money. Is better just only to tax in this with a temporary tax with this. Okay, so to finalize, we have that we extend the Ramsey result for heterogeneous agents. That is, we have that the optimal taxes are higher in goods that they are with lower elasticity in the aggregate demand. This will imply that the poorest people that are the ones that are going to suffer more about these taxes. These taxes are necessary to pay the bill that we must have. But in the case also that the social planner would like to default instead of paying the debt, the idea is that the final result is going to be more or less the same. The real allocation will be implemented, and in fact the effects observed in the first bullet, they also apply in the second one. And the third case, in the case of you have public employees, that doesn't help much to try to solve it out the current situation. You will have that it is better to tax them more than another type of, to have another type of taxes to try to cover this extraordinary expenditure. And that's all. Thank you very much.
Just in time. Very good, Juan Pablo. Do we have any question? Short question? Okay, thank you very much.
Okay, if anybody has a question, you can write an email to me and feel free to do it. So thank you.
Okay, thank you. So right now we are going to have Elias Suarez Campo, and he's going to present lack of prevalence of the endowment effect and equilibrium analysis.
Okay.
Okay, whenever you want.
Thank you. So, okay, I'm going to present the work lack of prevalence of endowment effect and equilibrium analysis, a paper that we worked with Aloisio Araújo, Juan Pablo, who is here, and me. We three are working in Brazil. And the idea of the general idea of the work is we were trying to integrate some results of behavioral economics with classical economics. And in some way, we are having some ideas of how an economy behaves when you have both types of agents. For example, agents that are that behaves according with prospect theory, and agents that are averse to the risk. So what we're going to show is if you have an economy with the two type of agents, some agents that are behaving according prospect theory and the other are risk agents, there are only two type of equilibrium in the economy. Yeah, and actually the first one corresponds to an autarky. So as the prospect theory agents has the influence of the endowment effect, they prefer to stay in the status quo, and the other agents are obligated to stay also in the status quo. And the other kind of the second time of equilibrium occurs when the aggregate endowment in hands of the risk-averse agent is large enough. And in that case, the prospect theory agents are going to behave as risk-loving agents, and the equilibrium point is gonna be a point in the frontier of the economy. So we have these two kind of equilibrium. In the first case, there is no there is no trade between the agents. In the other case, the economy is going to extreme consumption. So the agents are locating in the frontier of the economy. That's are the main results. And talking about previous literature, especially some experiments and some empirical results that we find in the literature. Of course, we have the influence of Kahneman, Thalers, that they show in different experiments the prevalence of the endowment effects in most of the participants in the experiments. So in that experiments, they show how the people are averse to, when they have some kind of endowment, they are averse to trade after some time. There are also works such as The List in 2004 that corroborates the existence of status quo bias. So they corroborate the idea of endowment effect, but by the other side, if the agent gain experience in the market, they behave more as a risk averse. And we also have another work from Miakov and Plot, and they show experimentally that individuals tends to be risk loving. That is so important for losses. But similar to the work of List, as the agents gain experience in the market, they tend to be more like risk averse agents, more classical agents in that sense. So our idea is to describe economies where you have the interaction of the two kinds of agents. What happens if you have risk averse agents and also you have prospect theory agents in the same market? So the idea is prospect theory agent does not want to lose money because of the endowment effect, and by other side, prospect theory agents tends to be if you have the utility function of the prospect theory agents, there is the side of the losses is multiplied by a coefficient lambda that is called the coefficient of losses, the coefficient of loss aversion, and they don't want to lose money. But once they start losing money, they behave as risk-loving agents, and that is very important because they prefer to stay in the status quo. But if they start trading, they are going to trade everything they have in that particular state. And we are very interested in to understand how the initial condition of the economy can affect the decisions of the prospect theory agent. So depending on what is the initial endowment of the agents, what happened with the economy, how the decisions of the prospect theory agent depends also on the initial condition of the economy. And we are going to use, we're based in another work from Aloisio, Juan Pablo, Chetenov, and Nowinski. Then they, in 2018, they proved that, or they work in economies with risk-loving agents and also with risk-averse agents, and they describe how if you have enough aggregate risk, you find equilibriums for the economy. And the idea is the next. If you have an economy, in that case, with two agents, a risk-lover and risk-averse agent, you find some allocations that are equilibrium, satisfies all the conditions for equilibrium, but the allocations need to be in the frontier. And in order to guarantee the existence of that kind of allocations, you need a lot of aggregate risk. So the difference between the wealth in both states needs to be very large. So in our case, we're going to consider this is a series of examples showing what's happening when you are working with risk averse and prospect theory agents. And we're going to consider an economy only with two states of the nature. We're going to consider only two agents. One of them is prospect theory with the utilities given by the next is you have risk averse agent, and the other one is prospect theory. The risk agent is behaving according the von Neumann-Morgenstern utility function. So we have here the linear combination of the utilities, where each utility is just a utility of constant relative risk aversion of parameter rho. And by the other side, you have the utility function for the prospect theory agents that is just the utility function find in most of the works in prospect theory, that is a function in which the utility has the shape of x of alpha minus lambda minus x to the alpha. And by the other side, we're going to consider, we also consider distortions of probability, because in prospect theory, you not only have the loss aversion distortion, but you also have the distortion of the probabilities. So we're going to consider that kind of distortion. That is something like that, in which the agents tends to overvaluate small probabilities and undervaluate big probabilities. So when we made all the calculations, we find that there are only two kinds of equilibriums. The corner equilibrium, as I told you, when you have big aggregate risk, and the Autarky equilibrium, if the value of lambda, that means if the coefficient of loss aversion of the prospective agent is too high, you have an Autarky equilibrium. And graphically, the idea is the next. If lambda is small and you have a lot of aggregate risk, and you draw the indifference curves of the agents, you can find an equilibrium very similar to the graphic I showed to you at the beginning. So all the conditions of equilibrium are satisfied in this point, and is that kind of equilibrium. If lambda is big, the distortion. So here we have, this is the utility curve, the difference curve for the prospective agent. If lambda is big, this curve distorts a lot and looks more like that, having some pikes here. We have this function, you have this kind of geometry, and there is a very strong pike in the reference point. In that case, it is easy to show that here in the initial point, the status quo can be implemented as equilibrium. So in that case, you have an autarky, and that is because lambda is big. If you compare the parameters of the both graphics, are essentially the same, but lambda goes from 2 to 7. That's the idea. And here we have a graphic showing what is the influence of the other parameters. So there are some regions, if you have the economy, there are some regions of the initial allocation when you can guarantee the existence of a corner equilibrium, or other regions when you guarantee an autarky equilibrium. So look here, in all those cases, for the autarky equilibrium, you have the line x1 equal to x2, because in the bottom there is no aggregate risk. So in that case, the autarky equilibrium region, depending in that case, if lambda increases, in that case lambda is increasing, the autarky equilibrium region increases, and the other region, the region correspondent to the corner equilibrium region, decreases. And there are also some regions where there is no equilibrium. And here we show the effect of increasing, in that case, the parameter rho. If rho increases, means that the relative coefficient of the agent is bigger, but it means the agent is less averse to the risk, and you have the opposite behavior. The region, that region decreases, the region of autarky, and that when rho goes to infinity, actually this region tends to be only the square, the line, when you have the same consumption for the both agents. And yeah, finally, we considered the case when you have endogenous reference point. Suppose that the consumption of the agent is stochastic, and the agent cares about the future. In the future, the agent doesn't know what's gonna happen, so the reference point maybe is not is going to be given in terms of on what the agent expects. So we have this functional form for agents having utilities depending on what's gonna happen in the future, and the reference point given by the spec value. And we have something very similar, this kind of functions representing also this idea of having a utility concave in the right side and convex in the left side multiplied by a factor of lambda. And we found something similar. We found for that kind of utility functions, we found something similar where if you have the initial allocation, maybe you are going to a corner allocation if the aggregate risk is high. And by other side, you have another cases where you move from the reference from the endowment initial endowment to another point where you have exactly the same consumption. Here you have the same consumption for the second agent, that is the prospect theory agent, and there is no risk for the second agent, and that is related with the fact that the spec value corresponds exactly with the distribution that he's going to consume. And we have some properties similar to the previous case. Here lambda comes from 2 to 7. So if you increases the value of lambda, it's probable that the economy, it's not, in that case, is not exactly an autarky.
You have 5 minutes left.
Okay, thank you. And in that case, it's not exactly an autarky, but you have a case where the prospect theory agent has exactly the same consumption in both states, and the reservoir agent needs to adjust his consumption according that the consumption of the prospect theory agent. At the end, if you analyze what is the general idea of what is happening here, is in some way the decisions of the prospect theory agents depends a lot on 2 different parameters. The parameter lambda, if the agent has large or small aversion to the losses, and by other side, we also see that here in these graphics, depending on what is the initial allocation, the initial allocation of the economy is also going to affect how the prospect theory agent is going to behave, because in some cases he's going to behave more as a risk-loving agent, and in the rest of the cases is going to behave as a person totally averse to make any kind of trade, or in the case of endogenous reference point, he's gonna choose an allocation that guarantee that there is no risk. And we have some propositions that generalize the examples. When you have a agent with this kind of utility functions, and the other one is concave, that is the other agent is risk-averse, there is a closed subset with non-empty interior where you guarantee the initial allocation is an equilibrium for the economy. We also have an analogous proposition for the case of when you have two agents in the Edward box. Actually, we also have a very precise formula in terms of lambda and related with the proportion between the probabilities of the states to guarantee or to describe when you have an interior, in that case, an autarky, or you have extreme consumption. And finally, we also have a very general proposition, when you have I reserved agents and J prospective agents that can also be agents behaving according to Juliet-Salanier. And if that condition is satisfied, that in the bottom is you have a lot of aggregate risk in all the states, you can also guarantee there is a equilibrium, and that equilibrium is in the frontier. And that's all. We guarantee the existence of equilibrium. To guarantee the existence of equilibrium, we must have large difference among the states, or the difference among the states is concentrated mostly in half of the risk or of the reserving agents. So that's all, and thank you so much.
Thank you. Thank you, because you are just in time also. Very good. Is there any small clarifying question? Okay, so thanks, Elias. And now we are going to turn to Victor Monteiro, who's going to talk about endogenous network under incomplete information.
Okay, so let's start here. This is a joint work with Diogo Guilhem. We're from INSPER, okay. And as the title is very suggestive, we're looking to an intersection between network on information, but how we lead with that? We lead with that in a macro model, in this literature of macroeconomics and networks. And when we look to that, we have an important motivation, okay? There are different papers, different setups to model this interaction between networks and macroeconomics, usually looking to the network's linkages as a source of misallocation, or how to connect individual decisions with the aggregate outcomes. But all of those papers usually use the same assumption, the assumption about complete information about the network. We can think information here in this case as the perfect knowledge about how is the shape of the network, who is the supplier at its level, who is the supplier of your supplier, and things like that. Although when we look at this assumption, we see this is a strong assumption. So our main goal here is drop this assumption and work with incomplete information. Think in terms of clusters within the network, okay, which is near to what we see in the empirics. So when we do that, new unanswered questions emerge, okay, questions about information and questions about misallocation. So we can connect this literature with the literature of incomplete information. So in terms of information, what you have here is basically the following. How the information could affect the draw of the network. Information should matter for instance, we find the linkages of a network. So when we change the degree of information for a given firm or for a given sector in the economy, it should change the linked information, the connections of this network, okay? And naturally, since we can have this channel between information and network, it necessarily could change the aggregate outcomes of this network, okay? So we can understand in these three sources here. Now, in terms of misallocation, usually we can think information as a tool of public policy, because The regular thing when we look to this literature on network is, oh, we have a distortion provided by this piece of the network, so we can use a subsidy to improve the situation in terms of welfare. But how we can think in terms of information? We can look to information and think that provision of information could be even better than provide a subsidy to a sector of the network or even to a given fund. Okay, so we dive in those questions, and today I will focus on the theoretical part of what we do here. So we build a new endogenous production input-output setup under incomplete information, where we have two main blocks. Okay, the first one is the micro block, where we embed the producer to find endogenously their suppliers through a decentralized such procedure, which is the standard procedure in the labor economics. Okay, and we find that the set of suppliers should be a function of the draw that we see in the data, so we can back up the results from the data. Okay, the level of information of this producer, the firm level characteristics, and those characteristics are basically profit, marginal cost, okay, and the prediction technique. While at the aggregate level, we can draw the optimal network and build two endogenous sources of misallocation to try to disentangle the impact of what comes from the network and what comes from the information side. Okay, from that we can tie this relationship between information misallocation, network formation. So in terms of theory, we model this endogenous network by the lens of the producer's decision. Okay, so information is directly related with the decisions of the producers in terms of set of suppliers and the inputs used to produce a given good. Okay, it will be clear in a few slides how we model that. After that, we show that higher the level of information, lowers the density of a network, more stable becomes this network. And in terms of macroeconomics, we show that higher is the spillover impact of a productivity shock. Okay, so information, it's very important, not only in terms of misallocation directly, but in terms of amplification effects, general equilibrium effects, okay, that we have here. We also derive under what conditions the provision of information is better than a monetary subsidy, as I said, and we design an optimal contract of public policy based on this idea of provision of information. We try to combine with a new database, okay, about daily payment transactions for the Brazilian economy, and from that we can estimate our model to find the value of a given level of information in terms of the output for a given sector in the Brazilian economy, okay, and calculate this idea of the amplification impact. After that, we will also provide a simulated counterfactual exercise to understand how these changes in the information could act as a public policy, okay. In terms of literature, we divide here in three pieces. The first one is the literature that dialogues with our idea of incomplete information. The second one is the literature on endogenous prediction network that provides the foundations on how we model our network. And the final one is the K-level of information, which allows us to dialogue endogenous production networks with incomplete information. We model the incomplete information through a K-level of information idea. So let's look to this simple example to understand, and after that I will enter in the model. So suppose we have the following economy, the network economy, with 6 agents, okay, 5 producers here and 1 consumer. So suppose that we have these W1 and W2, there are producers about wood, for instance, and this wood should be bought from this producer W, which uses this wood to produce a shelf of wood. And this shelf of wood will be used as an input for this industry I, combined with spikes to produce a bookcase, and the consumer will buy this bookcase. This is our idea of the network here, our production chain, and at the final node here, we are selling to the household, okay? So how we understand information in this environment? Let's look to the network of this player here, the industry I, And think first in the following point. Suppose that this industry I has only a unique level of information. So if this industry I has a unique level of information, this firm only knows one layer of the network, the layer of her suppliers, okay? This firm doesn't know the existence of the suppliers of the W. But now suppose that this firm discovered the existence of those suppliers and enhanced its information level to a second level, okay? So now this industry I knows two layers of the network, which means that the firm I knows the spike, okay, the firm that sells the spike, the W firms, and also knows who are the suppliers of those W firms, okay? And the draw of the network could change. For instance, this industry I decides to buy directly from W1 and W2 and calling this intermediary, okay? So we can have different draws of this network depending on the level of information, the choice of the set of suppliers. And those are the main ideas that we explore in our theoretical model. So in terms of household, we assume a pretty standard assumption, and in this literature, we are following a Acemoglu and Azar paper, okay, for the representative household utility function. In terms of production function, we also follow Acemoglu and Azar, but here we have an important difference, which is this notion of information matters and the production function of the producer, okay? So the production function has as arguments the set of effective suppliers, and the effective suppliers are the suppliers that the firm effectively chosen, okay? The productivity with respect to labor and productivity with respect to the inputs. Labor inputs, degree of information, now it matters because it impacts the set of effective suppliers, and all those things are conditional to the production technique chosen by this firm, okay? In terms of information, only illustrating the idea of the simple example, we consider that the level of information of a given producer is equivalent to the number of layers that this firm knows in her information set about the network. So when K, the level of information, is equal to 1, means that this firm only knows the previous layer, her direct suppliers. And when the firm knows Ki equals to capital K, which is equal to G, the total number of layers of the network, we are in a complete information world again, okay? So this is the idea of how we define our process of information. In terms of cost minimization, we work with a two-step procedure. And the first one, the firm should back up the set of potential and effective suppliers from the decentralized search procedure. And then the second one, this firm uses this first derivation to find the location of labor and inputs that minimizes the cost function. This cost function in the equation 3 illustrate this idea of the two-step procedure, okay? So in terms of our decentralized search procedure, we have the following constraint in maximization, where the firm should maximizes her profit, okay, weighted by the meeting probability, okay, subject to the constraint of be a supplier. We're calling that as the value function of be a supplier for this producer I, which is basically the profit of the suppliers weighted by the matching probability, okay? And now the difference here, it's important to highlight, is this summation term. We are summing according to all the levels of information that a producer has, okay? And from that, we can derive analytically the set of potential suppliers in this environment, which is a function of three important terms. This first term is basically the idea of an attractivity measure of be a supplier, because here we have the markup of the suppliers weighted by the elasticity according to the position of the network. Here we have an analogous result, but in terms of the producer. So how much the producer can spend to find the supplier and finding the better supplier or the best supplier as possible, okay? So that is why we have here the profit of the producer and the marginal cost. And the final one, we have an idea of market power for the suppliers, okay? We're not in perfect competition here, basically translating the notion that higher is the profit of each supplier that find those matches, okay, becomes more difficult to the producer find new ones, okay. So from this set of suppliers that we derived and the last proposition, we can find the effective suppliers of this fund, okay. So first we find the potential ones, and then when derived from this algorithm here, the effective suppliers, and those suppliers are basically the suppliers that provide the highest profit to this producer, okay. This is pretty simple, even though we cannot find analytical solutions for a complex network at this stage. In terms of our second step procedure for the minimization cost, I will not spend much time here. We have basically our cost function, which is pretty standard in this literature, and we can derive optimally the cost, okay? So in terms of equilibrium definition, we define the equilibrium in the following way, okay? An equilibrium is a tuple, and this tuple is of inputs, potential suppliers, effective suppliers, the price of those inputs, the outcomes associated with a contract between the price and the quantities of the inputs, and the producer's choice about the price of labor and the level of labor, such that each producer optimally chooses her set of potential suppliers. Each producer minimizes the cost from the allocations of those labors, okay, and the representative household maximizes his utility function subject to the budget constraint. Market for all goods clear and labor too. So in terms of macro report, and I'm concluding this result to show our most important result, okay, we have our notions of endogenous wedges. We have a network wedge, which gives this difference between the network output with a central planner solution to understand how is the effect of the network linkages in terms of distortions. And we have an analogous one in terms of information, where we derive the difference of in and output when we compare the complete information case with a k level of information. We can have k equals to 1, equals to 2, okay? We can work with all levels of information. So from that, we can derive our result that I talked in the beginning of the presentation, which is the idea of amplification impact of information. And this equation 11 illustrates to us the impact of productivity shock on the consumption of the household. And here we disentangle two effects. The first one is a partial equilibrium effect, which is the same capture in a standard models without networks. And the second one is a very
You have 5 minutes.
Okay, great. And the second one is our result of general equilibrium effect, okay, which incorporates the cascade effect that we have since we are model it embedding in a network environment. So when, for instance, we look to the simple example that I showed before, we have, suppose that we have at W1 receives a productivity shock. It should impact W1 production, W, because W use the W1 goods as an input, and it should impact consequently the fund I and the consumer. So we have an amplification here in terms of the effect of the productivity shock. And when we look to how information enters in this result and how information impacts this impact of the productivity shock, we see an interesting result, because we see that firms that have higher degree of information, so higher knowledge about the shape of the network, adjust even more their production when a supplier of the supplier has a productivity shock, okay? So information increases this amplification effect, which is very interesting for this literature on networks. And now the final result, which is the relationship between information and subsidy, how we can model and bring this idea to public policy, okay, to correct the distortions. We'll find this equation 13, which illustrates the comparison between those two sources of policy, okay? So given our network economy, if the value of the subsidy, and we can think here in a subsidy for a sector or for a fund, here we are defining for a given producer, okay? So given the absolute value of this subsidy, if it is lower than the variation on the real revenue of the firm, the subsidy is worse than an information enhancing policy. So we have different cases on information. Provision of information would be most important and most efficient, more efficient than we have a subsidy in terms of public policy. Okay. So only to conclude the presentation, our goal here in this paper using this theoretical model is build an endogenous production network under incomplete information, which is a new thing to this literature. But more than that, our goal is that this model should shed light on this interplay between the individual decision, the aggregate outcomes, how information matters for the network allocation. Okay, so we can interplay information misallocation network such that the provision of information acts as an instrument of public policy, amplifies the impact of a productivity shock on the aggregate consumption, and it could change the draw of the network. We can have more or less concentration on the network draw, depending on the level and the distribution of information according those funds. Okay, and that's all.
Thank you very much. You are doing just in time. Very good. Any questions? Okay, if there's no questions, I'm going to go myself right now. Oops, what's happened here? Okay, I'm going to present, I'm Federico Weinschela. I'm going to present this work on theft in equilibrium. This is joint work with Casilda Lasso de la Vega, who is in the University of the Basque Country, and Oscar Bolich, who is in Ben Gurion University. Let me tell you in 2 words what we are going to do. In 2 words, what we are going to do is we are going to introduce theft into the traditional Belarusian model. Also, theft have been modeled in different ways. There's nobody who has worked in theft in the traditional Belarusian equilibrium. Theft has and crime in general has much more work in empirical work, but in theory there is very few theories that work with this. So in particular, what we are going to do, we are going to incorporate into the standard quasi-linear equilibrium model. What happened with the traditional quasi-linear model when we are allowing to theft? This model will allow us to perform positive and normative analysis using the traditional Marshallian tools, and we are going to obtain results that do not depend on a parametric specification, on a specific parametric specification. This is not that we are building a model in order to answer a question. What we are going to do is we are using the traditional Belarusian model, and we are incorporating theft into this model, and we are going to answer different questions. The first things that we are going to do is that we are going to model 2 different scenarios. The thing is, the traditional quasi-linear model has 2 interpretations. In the model, you have 2 commodities. One is that it enters in a concave function, and the other that enters linearly into the utility function. And the one that enters linearly into the utility function can have 2 interpretations. The first interpretation is that this is money, okay? In the case that the linear commodity is money, there is no problem because you can steal the money. Okay, so it's in the first one, you can steal the whole wealth. So everything can be steal. In the second interpretation, in which the linear commodity is not money, but is time, you are enjoying the time that you are not working. So what you are enjoying is leisure. And it's much harder to imagine that somebody can steal your leisure. So we are using a second interpretation of the model in which only final goods are going to be stealable. This means it seems that it's a very small difference. However, what we are finding is that the results are completely different. Results are very different between one and the other. And what we are going to do is we are going to explain that. Okay. In particular, the second model, it produced a lot of very, very interesting results. So the first result that is sharing by both models is that criminal activity is a pure waste, and this is in particular the way that we model. And even for thieves, there is too much crime. The thing is, because the amount that is going to be stealing is like a common pool, so each criminal is going to look at the marginal returns. However, in order to maximize the total amount, you have to maximize the average return. So there's going to be too much crime. Right now, let me jump into the results that we are going to have in the first model when the whole wealth is subject to theft. This model behaves very well in the sense that it doesn't produce us many problems. The first result is that there is always equilibrium existence. There is always a unique equilibrium, and the unique equilibrium is stable. Okay, so it's have a very smooth behavior. Another result that we have for this model is that I have already said that the amount of theft is pure waste. So if we ask how a planner can solve the problem, one can say, okay, they can eliminate the possibility of having theft, but this is not possible for most planners. So what we are asking is there a way to subsidize something, for something that is possible to subsidize or to prohibit, for example, output, and improve welfare? So the thing is that we are finding in the first model that if the planner subsidizes output in a certain way that is able to increase the quantity of output that is going to be produced, and after that, people decide how much crime or how much jobs are going to produce. We find out in the first model, increasing the amount of output is going to make Pareto improvement allocations. Okay. Another result that we have in the first model is we are comparing the decision of private police, where each individual decides how much time he's going to dedicate to protect himself. And we found out the amount of private police is conditionally Pareto efficient. That means that the total amount of police is lower than the optimal. But given the amount of police that we are going to have, the social planner cannot redistribute police between people, and make Pareto improvement decisions, Pareto improvement policies. And the fourth important result that we're going to have is that in this model, always police is going to reduce the amount of crime. That means that if I'm going to increase the amount of police, the amount of crime is going to be reduced. Okay, there is a negative relationship between the amount of police and the amount of crime. And this is a question that the empirical literature has studied a lot, and there is not a definitive answer. And we are going to find that in the second model, this is not going to be necessarily true. Okay, so what we are going to have is that in the first model, everything is very smooth. Everything is very nice. In the second model, when only final goods are stealable, none of the above is necessarily true. None of the above results are necessarily true. Okay. Remember, this is the case in which you have that the linear commodity is time. So the commodity that you're going to enjoy that enters linearly into your utility function is leisure. So you think that, and we think that leisure cannot be stolen. So in this case, what you're going to have is equilibrium may not exist. When there is equilibrium, it may not be unique and it may not be stable. However, we find some conditions that guarantee existence and that guarantee uniqueness. But we have to impose some restrictions that are okay restrictions and not very hard to fulfill, but in general cases, we are not able to, we have examples in which there are no equilibrium, and we have an example in which the equilibrium is not unique. We are having that output subsidies are not necessarily Pareto improving. There are some cases in which you may have you need to have output subsidies, and there are other cases in which you have to have output taxes in order to reducing the amount of output is going to increase the utility. You have also that the private police allocation, if you have a decentralized economy and in which every individual decide which is the amount of police that he's going to have, the allocation is not necessarily efficient. That means that it is possible that a planner takes some policy from one people and give it to another one, and it makes Pareto improvement policies, Pareto improvement allocations. And an important result that we are going to, that we are working a lot on that is that more police can induce more crime. That means that increasing the quantity of police can increase the quantity of crime. Okay, these are mainly the results that we are going to have. Let me give you a summary explanation. Why is that? And after that, let me try to jump to the ones that I think are the more interesting ones. Which are the difference between both models? So we can conclude that the main results is that the results are very different when you have very small changes in the model. The big difference between both models is that in both models, markets affects crime. That means depending on the quantity of output, you are going to have different level of crime. But only in the second model, there is a feedback effect. That is that crime also affects the level of output. Okay, in the first one, the level of output is does not depend on the level of crime, but in the second one, since you are only going to have that, you are only can have still one part of the consumption, that is the level of output, you are going to try to produce less production in order to reduce the amount of crime. So the higher the crime, the lower that you are going to produce. The first model shows that with theft, you are not necessarily having an attractive result, such as not existence and all these kind of things. Only when theft has this feedback effect on markers, you have this perverse effect, as our second model shows. So, and this is probably the summary of what we are doing. Most of the results obtained under the first model are intuitive. However, they have not been obtained earlier in a general equilibrium model. And none of these results goes through when theft has a feedback effect. Particularly, note that it is possible that more police may induce more crime. Okay, let me check. The literature review, I am going to speak very low. I'm going to say that the problem of crime has been since the very beginning in the economic literature. Pareto, John Stuart Mill, everybody says that this is a big problem, and it has to be incorporated into the economic models. However, it is absent from the Belarusian model. The first treatment in theoretical terms is the paper of Becker, 68, and there are some papers that talk about that, but there's nobody who has incorporated the theft into the Belarusian model. Let me tell you a little bit about the model. There are two commodities. One is the linear one that is either more money or time, and the other one is peanuts. There is a firm that is able to transform labor or money into peanuts through a cost function CQ that is convex. We have a continuum of agents labeled between in the interval 0 and 1. And importantly, this is the utility function. That is the traditional quasi-linear utility function. You have X, that is the quantity of peanuts. And you have a phi that is phi Y, that is a concave function. And you have the linear commodity that it could be interpreted as money or as time, leisure. The individuals also has an initial endowment that is called omega I, and a share theta I of the firms of the profits of the firm. Okay. Let me skip this. This is the notation for the aggregate variables. Let me skip this. Let me tell a little bit about this. This is the appropriation technology. This is the way that we introduce the crime. The appropriation technology is a function from R2 to the interval 0, 1, where A sub Y T I is the proportion of individuals I stealable wealth that gets stolen when the crime level is Y, and he enjoys TI units of police protection. Okay, this is kind of the main thing that we incorporate into the model. That is an appropriation technology that depends on which is the amount of time that thieves dedicate to steal, and which is the quantity of time that each one dedicates to steal more safe. We define with a feasible allocation, that is a production plan and a distribution of different commodities, and it has to be feasible. That means that the quantity of peanuts that we are going to distribute among consumers is going to be the quantity of peanuts that we are going to produce, and the total amount of time or money is going to be dedicated to police, to protect the people, to steal, to enjoy, or to produce. This is the total amount of stealable income in the first model, and this is the total amount of stealable income in the second model. Okay, we are not allowing to steal the time that we are going to dedicate to protect, and the amount of money that, the amount of time that we are going to dedicate to leisure. We define the competitive equilibrium. There's nothing strange in that, but the thing is they are different in which are the budget constraint, and in particular the key thing is that the price of peanuts in terms of money in the first model is P, which is equal to the price that the firm is going to face. But however, when only earned income can be stolen, what we are going to have is that the relative price is P divided by 1 minus A, because in order to get 1 unit of peanuts, I'm going to pay P, but an amount A, they are going to be stolen. So I have to dedicate P divided by 1 minus A in order to get one unit. And this is, I'm going to finish. This is very a very easy way to understand this is there is a gap between the price that the firm is facing and the price that the consumer is facing in order to buy 1 unit of peanuts. And the thing is, this is very similar to the case of taxation. It's very similar to the case of taxation. There is a difference, that is in the case of taxation, this amount is going to be enjoyed by somebody, in particular by the government. But in this case, this is still, this is whole wasteful. And let me just finish with this, that in this model, in the second model, we can have a case, we can have cases in which if you increase the quantity of police, you are going to increase the quantity of crime. And this is a figure that follows from example 4 in our model, that at the beginning, when you are increasing the amount of police, the total amount of crime is going to be higher. And that's it. I have the conclusions, but I think that's enough. Okay. So I think we are almost done. Any questions of any paper? Miguel Sanchez.
Hi, thank you. I was going to ask you about your paper. I was wondering, so you are implicitly assuming that there is nobody that provides only police services. So there is no market for police services. The only ones that can provide protection are the individuals themselves. Right?
Actually, yeah, what we are doing is we are having 2 sections. In one section, we are assuming that police is provided socially. In this case, we impose one restriction, that is, it has to be homogeneous, so everybody has to receive the same amount of protection. And in the other case, in the case of private police, there is a price of private police, but it's not different that that we incorporate somebody who's going to provide police protection. The thing is, we're having, as long as the amount of police protection is given according, the amount of protection that is really produced is according to this appropriation technology that we have. So this doesn't depend if we put a TI, if this TI is the amount of time that I'm going to protect myself, or is the amount that I'm going to pay to somebody.
Yeah, but I could have, there could be heterogeneity in the ability to defend myself. Yeah. So if I can hire someone that is big and well-trained, probably the protection service is going to be better than if I do it myself. And I can also dedicate that time to do more productive activities instead.
Yeah, but I think this is similar to having a different appropriation technology. An appropriation technology in which TI is more productive than in the other.
But it would depend on who you attack then.
Oh yeah, yeah, certainly.
So in that case, you need heterogeneity anyway. And that's the other thing, the appropriation technology depends only on the aggregate level of crime. So it's like, it's random.
Yeah, it's random. Yeah, it depends on only in the aggregate level of crime. That means that the level of crime is not looking for somebody in particular. Is I'm going to dedicate some time to steal, and yeah, this is going to be this is going to affect proportionally to everybody at this, in the same way. Yeah,
because that means that implicitly my ability or my protection or the time that I dedicate to protect myself is not observable. Because if I have, I don't know, big fences and big walls around my house, and then my neighbor doesn't have them, it could be the case that they are targeted more easily. But you are not allowing for that. So protection
we are not allowing.
Observable.
Yeah, we are not allowing for that. Yeah, but the thing is, if you are protecting more, you are going to the amount that they're going to be stealing from you is going to be smaller. But yeah, the Y enters in the same way to everybody.
Okay, thank you.
Welcome. Okay. Okay, I think we are okay. We are 2 minutes early, but thanks to everybody. Thanks for the people from the Universidad del Rosario to helping us. And I hope to see you soon in a better way.
Thank you very much for the organizers. Thank you, Henry. And thank you for the other presenters. Bye-bye.
Bye. Thanks.